Hey there, and welcome. Today, we're diving into something pretty amazing, magnetism. You know, that powerful, totally unseen force that shapes our world in ways you probably don't even think about.
So you've played with magnets before, right? And you've got to wonder, what is this crazy invisible force? How does it just pull things or push them away without even touching them? It feels like actual magic, doesn't it? Well, guess what? Today, we're going to pull back the curtain and show you the science behind the trick.
Okay, so the secret weapon of any magnet? It's something called its magnetic field. Just picture this invisible bubble of force all around the magnet. And when the right kind of object wanders into that bubble, that's when all the action happens.
All right, let's jump right in and explore this invisible and, yeah, kind of magical force.
Because seriously, seeing an object just move on its own, it looks exactly like magic. But as cool as that is, it's all science. So let's break it down and see how it really works.
So a good question is, does this magnetic field just grab onto anything? Well, not quite. To really get what's going on, we first have to figure out who gets to play the game, which materials are magnetic, and which ones just sit on the sidelines.
You know, it really just boils down to what something is made of. On one side, you've got your magnetic materials. We're talking things with iron, nickel, or cobalt in them. These guys get pulled right in by a magnetic field. But then you have stuff like wood or cloth, and they just don't care. They're completely immune to the magnet's charm.
Okay, so now we know what a magnet can attract. But the really cool part is how it attracts and pushes away. And for that, we need to look a little closer at the magnet itself. Because you'll see, every single magnet has two different sides, or what scientists call poles. So how do you tell which pole is which? This is actually so cool. If you just let a magnet dangle freely, say on a piece of string, one end will always, and I mean always, point toward the Earth's geographic north. We call that the North Pole of the magnet. And the other end, well, you guessed it, it points south. So that's the South Pole. This is a huge clue about a much bigger magnetic secret, but we'll get to that in a bit.
All right, now for the main event, the big reveal. We know magnets have a North Pole and a South Pole. But what happens when you bring two of them close together? Oh yeah, this is where the fun really starts.
Let's try a little experiment, shall we?
Okay, first up, let's take two like poles. So, north facing north. Try to push them together. What happens? Whoa! You can literally feel them pushing back, right? They repel each other. Now, let's flip one of them around. So we have unlike poles, north facing south. Bring them close, and bam, they snap together. That's attraction for you. And just like that, with that one little experiment, you've uncovered the #1 rule of magnetism. Unlike poles attract, and like poles repel. It's that simple. And that single rule, it's in charge of every single magnetic push and pull in the entire universe. Pretty profound, right?
But here's the thing. This isn't just about a couple of little magnets on a table. This idea scales up in some absolutely mind-blowing ways. So let's zoom out and look at the bigger picture.
First off, let's talk about the biggest magnet any of us know, planet Earth itself. I'm not kidding. That's why the compass needle points north. Our planet's core is full of iron and nickel, and it creates this huge magnetic field. And this field is super important. It's not just for navigation, it actually protects us from nasty radiation from the sun. And this force is so fundamental. You can have a strong magnet work right through water. And get this, if you snap a magnet in half, you don't get one north piece and one south piece. Nope, you get two totally new, smaller magnets, and each one has its own north and south pole. How wild is that?
So that kind of leaves us with one final big thought, doesn't it? If the very planet we're standing on is a giant magnet protecting us, and this invisible force is strong enough to work through solid objects, just think about it. What else is it doing? Right now, all around us. It's just an amazing reminder that even with all our technology, there are these powerful, unseen forces at play, still waiting for us to figure them all out. Thanks so much for hanging out and exploring this with me today.